All right, let's talk about something we all use every single day: software. From the apps on our phones to the complex systems that run, well, everything. But have you ever stopped to think about what gives us the confidence that this stuff will actually work when we need it to? That's what we're digging into today: the invisible world of software testing. It's the whole process that makes sure our digital tools are solid as a rock.
Oh, we've all been there, right? You go to tap a button and nothing. Or even worse, the whole thing just crashes, taking all your unsaved work with it. It's beyond frustrating. It just completely shatters your trust in that app. So how on earth do developers keep that from happening? Well, the best way to think about it is to imagine you're building a massive skyscraper. You wouldn't just dump all the materials in a pile and hope for the best, would you? Of course not. You'd build a solid foundation, you'd test every single steel beam, you'd inspect each floor as it goes up, and you'd do a final walkthrough. Software quality is built the exact same way, in layers from the ground up. So here's our game plan, our construction plan for this little explainer. We're going to start with why you even need a blueprint. Then we'll look at how you test the individual bricks and beams. After that, we'll see how entire floors get put together, how the finished skyscraper is inspected, what happens during the client's final walkthrough, and finally, those crucial ongoing safety checks. First things first, just like any big construction project, you absolutely need a blueprint. For software, that means having a structured plan with multiple levels of testing. You just can't wait until the very end and then check if it works. You have to be building and verifying that quality at every single stage. And this diagram, it shows that blueprint perfectly. You see, we start at the bottom with unit tests for the smallest pieces. Once those are good to go, we move up to integration tests, making sure those pieces work together. Then we do a system test on the whole thing. And right at the very top, the acceptance test confirms that it does what the customer actually wants. Each level builds on the confidence of the one right below it. It's like a pyramid of trust. Okay, let's start at the very bottom, at the foundation. We're talking about the most basic materials here: the individual bricks, the steel beams. In the software universe, this is called unit testing. So what's a unit? It's the smallest chunk of code you can logically fence off from everything else, maybe a single function or a method. The whole point of unit testing is to put that one tiny piece under a microscope, all by itself, and make absolutely certain it does its one specific job perfectly. I love this visual because it makes it so clear. On the left, you see what developers work with, things they call procedures and classes. And on the right, it's just a brick. The goal here is to stress test every single one of those bricks to make sure it's flawless, with no cracks, before it ever becomes part of a wall. But wait, how do you test one little piece all by itself? Well, you use something called a test harness. So if you look at the diagram, you see a driver up top, which tells the unit under test what to do. And below it, you have stubs, which are basically stand-ins that pretend to be the other parts of the system. It's kind of like taking an engine out of a car and hooking it up to a special rig. That rig acts as the driver and the stubs, letting you fire up the engine and test it without needing the rest of the car at all. All right, so we're confident that our individual bricks and beams are solid. Now it's time to actually start building with them. We're moving up from the foundation and starting to assemble the floors of our skyscraper. This next phase is called integration testing. At this point, we're not so worried about the individual bricks anymore. We're focused on the mortar that holds them together. Integration testing is all about checking the connections, the handoffs between different components. Are they passing data to each other correctly? Can they talk to each other without causing errors? Basically, does one part's work flow smoothly into the next? Now, there are a few ways to tackle this. First up is the top-down approach, just like the diagram shows. You start building from the very top, say the penthouse, and work your way down. You use temporary placeholders, those stubs we mentioned, for the lower floors that aren't built yet. This is a great way to test the main logic and flow of the whole system really early on. And you guessed it, the opposite approach is bottom-up. Here, you start with the foundation and the basement, the lowest level parts, and you build your way up toward the sky. As you assemble each floor, you use special test drivers from above to send commands down, simulating how the higher levels will eventually interact with them. Or you can just do both at the same time. This is called sandwich integration. As the arrows here suggest, some teams work from the top down while others work from the bottom up, and they all meet somewhere in the middle. Honestly, this is often the fastest and most efficient way to get it done.
Okay, our skyscraper is built. All the floors are in, the walls are up, the roof is on. But before we even think about handing over the keys, it's time for a major top-to-bottom inspection of the entire thing. This, my friends, is system testing. So at this stage, we're done looking at individual bricks or even floors. We are testing the whole, fully integrated software as one giant thing. The goal is to answer one big question. Does this entire system meet all the requirements we set out at the beginning? Do the elevators work? Does the plumbing work? Does the security system actually secure the building? We're looking at the finished product. And that inspection is about more than just, does it turn on? We're asking bigger, more important questions. Things like performance. Can the elevators handle the morning rush hour without getting stuck? Reliability. Can this building run for months without a major system failure? Usability. Can people actually find their way around easily? And of course, security. Is this building safe from break-ins? So our building has passed all of our own internal inspections. Now for the moment of truth. It's time for the client's final walkthrough. This is what we call acceptance testing, and it's where the actual customer gets to decide if what we built meets their needs and is ready for the public. This final walkthrough usually happens in two main stages. First, you've got alpha testing. This is done in-house at the developer's office by employees who weren't actually on the project. Think of it as the final dress rehearsal. After that comes beta testing. This is huge. This is when the software is released to a limited number of real external users out in the wild. They use it on their own computers, in their own homes, and their feedback is absolutely priceless for understanding how it performs in the real world. You know, the job isn't done just because people have moved into the building. A skyscraper needs constant maintenance and safety checks to keep it in top shape, and software is exactly the same. So that brings us to our ongoing safety checks. Two of the most important ongoing tests are performance and regression testing. Performance testing is all about making sure the app stays fast and responsive even as more and more people start using it. And regression testing, this one is so critical. Every single time a developer fixes one bug or adds a new feature, they run regression tests. Why? To make absolutely sure that their new change didn't accidentally break something else that was working perfectly before. It's like checking that fixing a window on the 10th floor didn't somehow cause all the doors on the 20th floor to get stuck. You have to check. So, let's bring it all home. This diagram really sums up our entire journey, doesn't it? On the left, you see the development process, from figuring out what the client needs all the way down to writing the code. And on the right, you see a perfect mirror image, a matching testing phase for every single one of those steps, from unit testing, right beside the code, all the way up to acceptance testing for the client. The big takeaway here is that quality isn't something you can just bolt on at the end. It has to be built in and verified, layer by layer. You know, when you get down to it, this whole intense, multi-layered process, it isn't really just about finding bugs. It's about systematically building confidence. Confidence for the developers that their creation is solid, and more importantly, confidence for all of us that the tools we rely on are going to be dependable and secure when we need them most. So I'll just leave you with this thought. The next time you open up an app and it just works, it's smooth, it's fast, it does exactly what you expect, just take a second to picture that invisible skyscraper of testing that's standing right behind it, holding the whole thing up. Thanks for tuning in.